What we will see today is a scenario and proposed architecture. We will play a recorded demo of the system that we have built so far. We'll see some idea of centralized business logic using rule engine. We'll see the limitations of that. We'll look into an integration platform that we built as part of this, and summarize our outcome so far. Also, we'll take some questions and feedbacks at the end of it. So some of the opinions and conclusions are my personal. So you can raise your hand and ask and challenge. I would like to hear any feedback or opinion you might have at the end of it. The scenario for Shipowner is Shipowners Club, a marine insurance company, would like to expose some functionalities of their own on-prem internal underwriting system to their client brokers, business to business, so that they are capable to perform some underwriting activities like creating codes, bind policies, etc. themselves as part of a delegated underwriting authority contract. They should have options to enter data manually on the UI or upload bordereau file in XLSX or XLS format that might contain multiple records using a UI of a new user-friendly web portal. Terms of the DOA contract can vary from broker to broker, and the system should be able to handle those variations in contract in terms of pricing, in terms of various eligibility of how they do the business with them, templates and what kind of vessels and risk they can.
It's probably worth saying as well that it's a very sort of traditional industry, and the brokers are very set in their ways and they will do it their way, and ship owners need to be able to adapt to lots of different brokers doing different things. That's the real sort of point of the need for flexibility here, isn't it?
Absolutely, yeah. Nick said a broker should have access to some additional functionality that existing internal system does, and those are customized insurance pricing or premium for individual brokers, customized bordereau structure and data format, and validation rules as well, different for different brokers. Customized data enrichment for individual brokers. Enrichment is a process that actually defaults some values, because on the UI broker don't provide all the data that's needed. So we have to default some of the values, and that can vary from broker to broker. And finally, the orchestration, basically automate the multiple processes that an underwriter does in the internal system in different screens. We have to kind of orchestrate that process, and sometimes it has long running processes. Therefore, for example, they have raised a referral and they have to some user with higher authority have to approve the code before it can be bound into a policy and stuff like that. And also there are some others that came along which you needed to handle. Main thing here is the challenge that we have is the pricing that it starts with, and the bordereau different file having different structure, and the files have many columns, 50 to 60 on an average. So it's quite a challenge to actually have those kind of variations. But we will look into this a little bit more detail later. So this is the proposed architecture. This is a simplified version of the original diagram, just for demonstration. So two scenarios here. One is the broker will enter a quote inquiry, we say that, on the UI, and then they will get a pricing via this inquiry API, and using the rule engine. We have a wrapper for API here. Because it's in rule, we just put a wrapper there. It doesn't do anything itself. It just calls the rule engine and gets the response for the pricing request, for example, and pass it to the UI. And for all the operations that we have rule engine related, it goes via the rule API, this wrapper. Once they created the code, it then passed to the on-prem system via this integration platform. And again, all of these are asynchronous, so we send messages to the topics, and it processed on their own time and nicely orchestrated in the integration platform the way it's needed. That's both for bordereau upload. So if bordereau uploaded, then it needs to check the structure match with the agreed structure for the broker, and that check happens using the in-rule configuration that they have for the broker. And a bordereau file can have different type of records. It's not just the new codes; they can have renewals and all sort of other things that we have to kind of separate and process. These are the two processes, the high level processes I just put here to visualize. First of all, a broker goes and creates a new code on the UI. They can save it, they guess the price, they calculate the total, initial validation happens. All these orange ones happens using in-rule, rule applications, and the blue one is the inquiry API, and blue one with red is the user interface. And here is the on-prem system. So as you can see, the processes is quite straightforward, but they are done in a way that they are reusable and handles multiple variations and configurability of it. Enrichment is one of the biggest part as sitting here. That's not just for the UI creating new business code. If they upload a Bordeaux file, again, there are some extra bits to do here. When they upload the file, it is scanned for the virus. If no virus is found, it then process further, check the file and structure validation based on the configuration in in-rule. This happens, as you can see, in the inquiry API. It's extraction of the check of the structure and the extraction of the data happens into the inquiry API, but it happens using the rules that's set by the user into the rule engine. So it's a bit tricky here, but it's very effective to handle multiple variations of those files. Once that file data is extracted, it goes to format the data, because it's not just the data that's the structure that's different, it's the data itself have multiple formats, so that needs a standardization, different formats of dates. Even the data that we see in the file are different for different brokers. We will have a look later, but we need a formatting of the data and then bringing them into standard format, then validate the records, and then transform the records into the quote inquiry, and then follow the same initial validation and enrichment, and then further processing using the integration platform via the integration platform into the on-prem underwriting system that we have. As you can see, the on-prem system is quite straightforward looking here, but it is in itself there are some complexity that we have to deal with, which we will not go into detail, but having this integration platform helps us orchestrating the processes that we need to perform here. So we will look into a demo of this. This is the portal interface that I'm going to show you. Log in with a user, Azure ADB2C. It will send a verification code to this email address. This is the dashboard. I've successfully logged in. Here I can do mainly two things that I will show you. Is first of all, this is the area where the user can create codes for members. Codes are marine insurance code. So there will be vessels, they can add vessels, members, and it will get the pricing, automatically get the covers that's appropriate for that vessel. And also I will show here you can upload Bordeaux, that kind of same thing that the interface does when they add one by one, but Bordeaux can have multiple of those codes in an Excel file, which I will show later. For now, let's go to the new code, create a new code. This is the policy start and end date. I'll select, I'll add some vessel detail. So this is my vessel name, a year build. So all these parameters for the vessel affects the pricing. As you can see, there is no total shown because we don't have enough information here to get the pricing. So once we fill out all the required information, it will then get the pricing. So as you can see, we have put enough information now for the vessel so that it can get the pricing. So the pricing is a module, is a tool developed into the rule engine that's highly configurable. It depends on the broker that logged in, the product they have selected from here. You can have multiple products, multiple templates, and based on that broker and templates, we get the pricing based on the parameter that they have entered. It's not just the pricing; it also gives the covers that is appropriate for that vessel, and also the pricing for that cover. And it has given this cover as a mandatory cover. Some of the covers are optional, like this one, but we can add it. And it also calculated the price from the pricing engine. At the moment, the users can change this pricing as well if they want. They don't have to take the suggested price, and it will automatically update here the detail. So that's the interface where we create the new business code for a template that is
available to them. So once this is created, so this is now created, I can save it, I can bind it. Bind means the finalizing and creating the policy, but for now I'll temporarily save it, and we'll see how it's saved temporarily. So I've saved it, and this is the first one that I have. I can come back and reopen and go and bind it. So that's what I'm going to do now. Bind. It will tell me if everything is okay. Everything is okay. It's done the validation. Again, the validation happened in rule engine and checked all the data provided match with what is needed. So now I can accept and bind it. I will go ahead and bind it. So this is our test vessel number 4. So now it is showing us here that it has been submitted. So for user, that's where it ends. It is submitted, but behind the scene, it is doing lots of stuff. First of all, it has enriched the data that's been provided, because the on-prem system needs more data than what the user interface here captured. So the missing data is defaulted using, again, the rule engine. So I'll try to find that the one that we have created. So it should be 4. So its status initially is processing. That means it is still processing on the backend side. We'll see what those processes are, but for now it's processing. So this is the backend system that that code that was created should finally come. So let's see what we have. So if we search for that, you can see that vessel that we created, test vessel 4, is here, entered. So that means that it is successfully bound. So now if we go into the database and look at the status of that, it should now be bound. It is now bound. So in the system it is bound, and also it is updated the cloud database when the binding is finished. Now I will show you the board reprocessing. This part is still under development and not ready for complete end-to-end testing yet. I'll just show you how it's working currently. Board reprocessing is particularly complicated task, primarily because different brokers can have different file structure and format. I'll show you 3 different brokers. As you can see, this one is the first that have a board file with some data. As you can see, the structure here looks like this, and if we look another file for another broker, that's the structure is completely different. Underlying data are almost the same. I wouldn't say exactly the same, but the structure here are completely different. And the main reason is, I think, brokers deal with multiple insurance companies like shipowners and have their own file format and structure that the shipowners and other insurance companies are expected to deal with. So we end up with even the same broker having multiple format. For example, this is a date. As you can see, even in the same file for this broker, the dates are completely different. It's not just the presentation of the data, the context also can be different. For example, if we look into the navigation area that a vessel can cover, here we have a different kind of grouping of regions in the world. Can be different to, for example, this one, trading area it's called, and they might have different grouping of the navigation area, but shipowners have to deal with these areas. That they might have multiple, one can be split into multiple navigation areas and multiple can be combined into one. The presentation here is different, but also the context. Also, some broker can have multiple sheets. It's spread across multiple sheets. Some of them might have single sheet, for example, this one. So yeah, we have different layer of complexities here that we need to deal with. So what we have done is primarily data and structure and the validation is done that I will show. So upload the file. So I have changed the structure so that it is invalid for this one. So confirm and upload. So first thing it's doing is virus and malware check. It is sending to a file service that will scan for file for the virus. If no virus is found, it will upload into a blob storage and return the ID of the blob storage, and then UI will send that ID to the backend processing. And that's what it has done. It didn't find any virus, but it found a column is missing. This column is particular for this broker, and add that column back. And hopefully, it will now identify it is a valid port profile for this broker. Start renaming this. Now, as you can see here, it didn't find any problem in the structure, but it has found some problem in the file validation. If we look into the database now, we will see actually what is that problem. For user, it doesn't matter. From user perspective, it has uploaded the file, and now the operations team have to deal with any further issue with the file manually. They can do that. So let's see what are the issues of the file that we uploaded. This is the file we uploaded, this one. As we can see, it has actually shown the main error, but when processing, it has found one valid record into the file that it intended to process. And this is the raw item that actually extracted from the file, with all the columns that the enroll is interested, was extracted from the file. A raw item is always text, because we extract the text from the file, and then based on the settings for the broker, we can then from those raw items we map to standard item, which we can see here, the policy start, policy end date. These are formatted data brought into common format for all the brokers. But when we extracting the data, we also extract into common field. The data type can be different there, and it doesn't really matter. Based on the brokers, we can standardize whatever format the data is given. Based on the broker, we can then parse the record into standard format that is up here. So we have both the standardized version of the record and the raw item. The reason is that raw item, we can use it if we reconstruct the file, which is a requirement. Then we have to reconstruct the file with a report of individual fault messages. As you can see, the fault message here, it is saying that there is an issue with the invalid date validity. So that means that there is a property date validity and that field is invalid. So these are the kind of detailed validation we get for each of the rows and each of the columns that we have into the border file. Now if we go and log out and log in as a different broker. Now I have logged in as a different broker, and this is the file structure for them, which is completely different. Then I upload the file. Confirm. So it will do the same. It will scan for the virus, and then we'll send for further processing. Now it has found missing. Now this column is again specific to this broker, and showing the exact name of the column that's missing. Let's upload the file again. So hopefully it will not find any structural problem right now. Confirm and upload. It's again doing the virus scan. And then if no virus is found, upload it to blob storage and send the file name as an ID to the backend for processing. Now it didn't find any problem in the structure. It's saying there are some issues. At this stage we're not worried about it. That's the customized DB where all the file upload records are extracted and stored temporarily. So this is the attempt that we made, and as we can see, it has an error fault message. There was one record that was extracted for processing, and we can see again the raw item that is extracted from the file, and there are a few issues there that's listed here. Member reference cannot be left blank, city cannot be left blank, there are a couple of blank fields there, and domicile cannot be left blank. So there are a couple of blank fields that it was expecting. The reason this fault for this row is that we can reconstruct this file with a report that can be sent back to the brokers with these errors for each rows in the file. So that's the reason we preserve the raw items that extracted from the file, standardize them, and then we transform these records into a coding query that actually match with a structure that we have for code creation and bind. That's how the board will be processed. Again, using the rule engine for doing the extraction of the data, validating and transforming.
Question, can I ask a question? You want to-
Yeah.
Quick question, the malware or the virus checking, is that using Azure Defender for Cloud? Do you upload the file to blob storage and use now with a third-party service?
No, it's not. It's using Sophos. Sophos file scanner. So we have
inside of VM, or is that a PaaS thing, or what?
No, it's a PaaS thing.
Yeah, so this application is calling that and saying here's an Excel.
Yeah, so from what happening in this case is we build a Azure function that calls the Sophos static file scanner. So it calls directly to the Azure function, and Azure function calls the Sophos.
Yeah.
And if everything is clean, it then uploads the file into blob storage.
Yeah.
That holds only clean files. If it's not clean, then it just scrubs the file there. And
I do recall some discussions, which I wasn't fully involved in, of being able to run Sophos on a container instance or something inside your network. So I know the sort of thing that Chris is probably thinking about there.
They've got a challenge at work, but similar, and they're saying, should we use Defender for Cloud, the blob storage checker, or should we use a third party? The malware checking Defender for Cloud is quite good because it comes back within a couple of minutes, but you have to give the user a holding message. So upload an Excel, go make a coffee or whatever it says.
Yeah.
Go make a coffee, come back after a coffee. Oh, yeah, file's fine. Whereas that's more real time, so a bit of noise. That's quite fast, you see.
yeah, it's quite fast in that sense. Yeah.
I think if there was sensitive data in there, then there was options to monopolically read the premises as well by using the same solution.
That's the benefit.
Yeah, it's the configuration, how much deep we want it to look for. For our case, it's no, we don't need it too deep to be searched. It can actually search the content itself, and there are lots of variations how we can configure it. The way it's configured serves our purpose, and it has a rating of between say 20 to 70. That means that it's not, we can consider them as safe, but there are variations that how we consider. And so what we have here is a concept of centralized business logic using rule engine. We have different applications and services that have configurable business logic. The idea is to put all the configurable business logic for all the API or services in one place so that they can be modified easily and maintained in a certain case by business users and SMEs instead of developers, and we need releases and stuff. So it's quite effective in that sense. So rule engine, like InRule, provides a mechanism to create, store, and execute centralized decision logic. It works based on simple request and response structure, where a client sends a simple JSON request and receives a response back in JSON format, which is an updated state of the model that was requested. So InRule has these components. First of all, a desktop application to author the rules that looks something similar to this. It gives an interface basically where you can hold your primary data that you want frequently changeable. So it's a, even though it looks like a table, it's actually controlling some logic and rules behind the scenes. So we can change these ones easily. We can say this broker is no longer active. We can deactivate, and we can give them, say, this broker no longer can upload file, and this broker can no longer use the interface to create code, and give them those functionalities that they have a fine-grained control on what the brokers can do. And this interface helps the SMEs to control that. Obviously, there are deeper things as well that probably SMEs wouldn't do. For example, we can do some calculations here in the entities, as you can see this one. So this is a risk calculation, and these are calculated fields. So as you can see, this is a calculation that anyone who knows this calculation can go and change them as they need it. I don't know why they put 8.5, but that's how hard they do. And so it allows them to do basically anything that they want to do in their world. So this is the desktop application. We have self-hosted or SaaS model for holding those logic. So it's when you create a rule application. So this is a rule application. I can save it as a file. That file needs to be hosted somewhere. So it's even though it's a file, it's a zip extracted zip file in Excel format. XML format. So there are lots of XMLs in there that zipped into one file and just renamed it to the extension that are valid for them, and hosted it into our catalog. And a catalog can hold multiple of those rule applications. Once hosted, those applications can be then executed by the rule engine. So that's the self-hosted execution server. So rule execution server that actually called via the client. So this is where all the applications calls. The rule execution server grabs the application file from the catalog and executes them. So that's the overall structure architecture for the in rule.
What would happen if they didn't have that? So the business asks for that, basically, to say, to make a change to application logic or the data, we have to go to IT. We don't want to go to IT. We want to do some basic bits ourselves because we want to shorten the loop.
Yeah.
Is that what they've said? This new app, I'm sure, but we want to do some logic ourselves, please.
Yeah.
That request from business, right?
Yeah.
Okay.
Effectively, that's what it is.
Go and speak to IT if we can help it.
And when we were going through this, I was saying, well, you know, what about rule DevOps and deployment and pipelines and testing and all of that sort of thing? And I think the short answer to that is they can't do that much tweaking in here, but it's enough to mean that there's a lot of IT requests that are short-sighted, but it doesn't then warrant the full software development lifecycle.
Yeah, effectively that.
So is that a product off the market, or you've made it? It's a
product.
It is a product, yeah. So this is an example request for pricing. So as you can see, it has basic information for the broker, which template they are using, and the basic information for risk. What are the vessel flag, gross tonnage for the vessel, broker navigation areas that it is looking for, some other properties. So once we pass that, it gives us a risk, but it gives us the covers that that risk can possibly have. And also it gives us the premiums that we are looking for. So these are the bits that's added from the rule engine into this data entity state that was provided into the request. So we get entity state in the request, we update the entity state and send it as a response. So that's pretty much it. That's the pattern for all the rule applications. So whole idea is that we have an application that have business logic, and we want the business logic to be in rule engine. And another thing that we followed is the dynamic data model. So we don't have any concrete data model in the API. The concrete model is in rule, the rule engine, so that it can be dynamically changed in rule sites, and application doesn't need to change to accommodate with the changes. What we have here is an API or service that we strip off all the business logic and move those logic into the rule application hosted in rule engine platform, and that work based on a simple request response model. If we move to another thing, I think I want to say that success of this is depends on how we put the boundary of what business logic we want in rule engine, because it's a big decision. If we do half and half, and later on in the process it doesn't work fully in the rule side. So making that choice of what logic and on its entirety of the life cycle, bring it to the in rule so that it doesn't create conflict with all the other things that we want to keep in rules API. So, and the success, I think, mainly depends.
Rules in like guidelines in as well.
Yeah.
I remember you saying, you know, you can dive out the back of in rule, go and start looking at other things from while you're executing the rule, and you don't allow that because that makes the rule in state rule, and then it won't scale. And so.
Yeah, effectively. So yeah, the measure of the success would be how fast we can develop the whole thing, how easy it is to maintain, how easy it is to make future changes or expansions easier. So limitations, the price, it is quite expensive. A typical license fee range between 120K to 170K per annum. So yeah, it have 5 developers, 5 developer licenses, 2 catalogs, and 2 servers, 2 execution servers, and 5 developers can have 5 licenses for our author. So
I think, so talking to some of the senior guys in the customer, it puts them having to make a decision. Do we move everything in here and get good value for money, or do we not use it at all? It's not something you use halfway house. Yeah.
Yeah. Learning curve, not every developer, .NET developer would like to or be able to work with. It's it's some developer find it's too easy to work with, just don't like to work with it. And once you get one of them, it's hard to get anything done. So it's a bit tricky there. But if someone likes it, they love it. They don't. They will be really productive and pass things out very quickly. Development, the built-in tool to see differences between two versions of the application has limitations. It makes review of the rule very difficult during the development phase. There are developers unfriendly workaround for it. And the testing tool that we have to do the unit tests and stuff, that also is not great. It is tricky to do the initial bit. Once you have all the folders and things in place, then you can add things quickly. But creating that structure for application is really a nightmare. This is the integration. We have the inquiry API here. Broker uploads the file or enters the record. It goes via the integration platform. First of all, inquiry adapter. It holds all the initial, say for example, they want to bind 50 codes, and 50 of them comes here one by one. They send to the UTOM adapter, which the adapter for this API, on-prem API. And from here, all the codes one by one orchestrated through all the stages that it needs to go. So first of all, it creates and issue the code, and then code assess the code, and then it issue, and then it bind the code at the top. Three activities that you can see. They are asynchronous, so we might wait for each of the stages to complete for certain codes. This is the summary. The system works. It's partially live and achieved all the milestones so far. Integration platform was effective and efficient in handling unexpected and new orchestration requirement to perform operations into on-prem underwriting system. Rule engine and rule applications were quite effective to onboard new brokers with new pricing and board processing requirements. So there are some references here for Enroll and Microsoft Rule Engine that we talked about as well. So yeah, if anyone would like to play with them.
So you're doing a lot of your file import, but you're doing it all in functions, or are you using any of the kind of middleware type, like logic apps or anything like that?
So we have the API, all the extraction happening in the API, inquiry API. Okay. So inquiry API gets the configuration from Enroll or a particular broker, and then it knows what it's expecting in the file. If it doesn't find it, that means it's a structural mismatch. If it finds it, then it just...
So sometimes you've got to do lots of custom error handling, data correction, maybe.
Yeah. So all of this done into the in-rule. So once the extraction happens based on the configuration, then all the data passed to in-rule to validate using those rules can be changed, modified for a particular broker as needed.
And how did you do the traffic between the Azure into the on-prem API?
So on-prem, we have durable function. So it's a HTTP call that goes in on-prem API.
Also like direct, anything in between?
No, it is a direct call from the adapter, from the Azure durable function to the on-prem authentication. There are authentication in place. We have managed, we have authentication, managed identity to be able to call.
So you don't have anything on the network layer?
Yeah, so it's an elastic premium plan that's connected to a VNet, which goes through a software virtual WAN, which goes through a firewall, which then goes through a firewall on-prem as well. And the networking is protected like that.
So you have to go through the firewall, you have to open up the firewall. All the environment have got their own.
It's got a firewall in the hub, and it's also got some kind of VPN device firewall on-prem as well.